So this week we're still looking at types of energy, but we're actually going to look at how we can calculate gravitational potential energy, and tomorrow calculate kinetic energy, and in fact how we can then use that to calculate some interesting things about speed. Okay, so just a little reminder, because we have been looking at heat recently, so just a reminder, it says trying to change the slide, okay, that energy is a quantity that we cannot make energy, we cannot destroy it, we can only change it, and in physics we say we can transform it. So the total amount of energy always stays the same, and remember energy is measured in joules. That's a picture of joule there. Okay, and we have different types of energy, so we can change from one type to another, but the total stays the same. Okay, now I'm going to take you back to last week's lesson now, when we were looking at work. And if you remember, work is the amount of energy we change when a force moves. And we looked at some examples, and one example we did look at is when we lift an object into the air. Because of course we're using a force to lift the object up, and of course when we're moving upwards, we are of course moving in the direction of the force. So there we are doing work. And if you think about it, when we do that, we're converting kinetic energy, the chemical energy in our body, into gravitational potential energy. Yeah, and at some later date, if we were to let go of the weight, that gravitational energy would then change back into kinetic. You can see where we're going with this, can't you? Okay, and of course the force we use to lift is equal to the weight. Okay, so once we're moving that weight upwards at constant velocity, remember, if at constant velocity, yeah, there's no resultant force, so the weight downwards must be equal to our lifting force. And we use that to calculate the work done when a man lifted a mass of 120 kilograms. And remember, the key thing here was we first of all had to find out the force we used. And remember, to convert from mass to weight, we multiplied that by the gravitational field strength, G. And if you remember back in topic 1, we did weight is mass times gravitational field strength, W equals mg. And so we were able to calculate the work. Now, if you think about it, the amount of work we've done, it's actually the amount of gravitational energy. So that work has been turned into gravitational energy. So this number here, the work that we did lifting the object, is equal to the gravitational energy. So that's where we can get a formula from. Yeah, so gravitational potential energy, we sometimes write it as GPE, is equal to the mass times the gravitational field strength, because those two together are of course of the weight, multiplied by the distance we've moved it up, which of course is the height. So we write it like this: GPE equals mgh. That means mass times gravitational field strength times height. Remember, on the Earth, g is around 10, and in most of our questions we'll take it equal to 10. Okay, so if you could just pause the video and you can copy that down, that's another formula we need to learn. Okay, so let's have a look at some examples. A woman lifts a small dead dog of mass 5 kilograms to a height of 1.52 meters. How much gravitational energy does the dead dog gain? That means how much has it now got compared to when it started. So it's gained, it has now more gravitational energy. Okay, so as usual, yeah, physics is really simple. We write the formula down. That's probably the hardest thing, is remembering that formula. Okay, we then put the numbers in. Okay, so the question tells us the mass of the dog is 5, that's m. We're going to assume it's on the Earth. An IGCSE question will tell you what G to use. We're going to assume it's on the Earth. There's only been one dog in space, like that, I think we've talked about. Yeah, so on the Earth, G is 10. And of course, we've lifted it up. The height of the dog is now 1.52 meters. This formula must use meters, like all other formulas. You stick that in your calculator, so it is gained. It now has more, 76 joules of gravitational potential energy. Remember, that's because the woman did work by lifting the dog, and that work was turned into gravitational energy. Let's have another look at another example. Okay, a dog of mass 12 kilograms, so this is a slightly larger dog, falls from an aeroplane at a height of 3.4 kilometers. So this aeroplane is 3.4 kilometers in the air. So straight away you've got to think, hold on, Our formulas don't use kilometres, they use metres, so we're going to have to change that. How much gravitational energy does the dog have as it leaves the aeroplane? Okay, so let's look at the questions told us here. So in physics, we're sort of, we're taking the question and trying to look at the numbers there. So we know the mass of the dog is 12 kilograms, it's told us that. Again, we're going to make this assumption. The question will remind you of this, that we're on the Earth. There's been no aeroplanes as far as we know anywhere else. And we've got the height. And you can see here I've done the conversion here, 3.4 kilometres. Do you remember last lesson we said that to convert from kilo, last lesson it was kilometres to metres. Yeah, we multiply by 1,000 because there were 1,000 metres in 1 kilometre. Kilo means 1,000. 3.4 kilometres is 3.4 thousand metres. So it's 3,400 metres. Okay, and again, we write down the formula. Gravitational potential energy is mgh. Okay, then multiplied together, m is 12, g on the Earth is 10. We've just discovered that the height is 3,400 metres. This is the amount of gravitational potential energy. Okay, so that's basically what I'm going to ask you to do today. I'm just going to make you think about something ready for tomorrow. So if the dog's thrown out the aeroplane and it starts off with 408,000 joules of gravitational energy, how much gravitational energy does it have just before it hits the ground? So if you imagine just a fraction before it hits the ground, and what has that gravitational energy turned into? And that's what we're going to talk about tomorrow. Okay, so there is a question here. Okay, lesson 9, calculating gravitational potential energy. I'm just going to talk about the very last question on the worksheet, which is this one here. Yagma on Earth drops a ball of mass 0.5 kilograms from a height of 2 meters. First of all, it says how much gravitational does the ball have before it is dropped. So I want you to calculate how much energy does it have when Yagma is holding it in the air. I don't have a ball, I've got a small mole. Okay. How much gravitational energy does it have just before it hits the ground? So imagine that she drops the ball. I don't think I can show you this. Yeah. Just before it hits the ground. Yeah, so it's fallen down. So just before it hits. And then it says, how much kinetic energy does it have just before it hits the ground? So I want you to think about the energy changes there. You don't have to do any more calculating. Okay, that's it. So tomorrow we're going to, I'll remind you of this, and then we're going to look at kinetic energy and how we can calculate that.